Yes, students, one more proof. We have the relationship between volumetric expansion or cubical expansion and density as rho I equals rho F bracket open 1 plus gamma delta theta close bracket. That is the relation. So when it comes to density, it's unlike volume where you have Vf rather being Vi. You see, for density, it changes. This is V. Density doesn't work like that, right? For density, the initial density is given by the final times that. How do we prove that? I want us to look at it. All right. So where do we start from? So the proof. So let's say that let's consider a solid, okay? A solid of mass m and initial volume v. It is heated through temperature then how do we find the cubical expansivity? Gamma, we know that is what? Change in volume times change in temperature, right? Which goes on to say that this can be rewritten as gamma Vf minus Vi over Vi times change in temperature, right? So what is our Vf? Our Vf, making it a subject, is Vi 1 plus gamma change in temperature. Let me call this equation 1. All right. And we know that the body has mass m. So we dividing equation 1 by m. When we divide through by m, what do we get? We get Vf, okay, over m is equal to what? Vi 1 plus, okay, gamma delta theta also over m, right? Because Vi and the one in bracket are multiplying, they become one entity. So we can rewrite. Let me divide my board. I have only 2 pages to work this. So Vf over m, I can rework it as this. Okay. Yes. Because this is over 1, and when you multiply, you get back that. But we know that, but density rho is given by what? Mass over volume, right? Do you know this formula already? Okay. So then can we say that, then it follows that Vf over m will give us the final density? Is that not it? And Vi over M will give us the what? Initial density. Is that not it? But check our equation well. Oh, let me. Yes, the I is not. The dot is not coming. Okay. So it is. Sorry, I've made a mistake. Density is mass over volume. So sorry. Mass over Vf. Mass over volume. Then mass over, yes, will give us density. All right. So what can we say here? Then, if mass over volume will give us final density, then can I say this, right? Can I say that Vf over M will give me 1 over this? Vi over what? M. Can I say that? When I invert it, I'll get this. So let me call this equation 2. Yes. So from equation 2, we can write that, okay, the Vf will give us what? Vf, the Vf over M can be indicated as this. Is equal to what? 1 over rho I 1 plus gamma delta theta. Is that not it? And here, if you check the equation, well, rho I has been made the subject. Okay? So when I multiply, when I cross multiply, okay, when I cross multiply here, what do we get? I'll get rho I equals what? Rho F. So that is the proof. That ends the proof. Very simple. You consider a solid, if the solid has mass and initial volume Vi, Vi, it is heated through this temperature, then we know that the cubical expansivity is given by this. Okay, so here, where Vf is the final volume. So here we just made, from here you made the Vf the subject. And we get that. So you get this. Then we divide this through by M, by the mass. We beautify the equation. We get this. We know that density is mass over volume. So mass over volume will give us density. So what about volume over mass? It will give us inverse of density. So we are just putting these ones into equation 2. This equation 2. So it means that here will be rho. That here will be 1 over rho f, then here will be 1 over rho I. And that is what I did here and here. I hope you are following. All right. So from there, we just cross multiply, then we get our equation. All right. Thank you very much for joining. I'll be looking forward for your comments and your questions.